Hello, I'm Tanner, and this is my presentation on the Marangoni effect and its influence in engineering applications. Next slide, please. So, the Marangoni effect was first discovered by James Thomson in 1855 when he observed how wine reacts to the rims of cups. Further investigation was done by Carlos Marangoni, who was an Italian physicist in the 1860s, where he further observed the behavior of water and other liquid surfaces. Next slide, please. So, what is the Marangoni effect? The Marangoni effect is the study of is how fluid motion is caused by a gradient in surface tension. So what happens is fluids automatically have a natural contractile force that keeps liquids in static equilibrium. And the disturbance of this force due to surface tension creates what we call the Marangoni effect. Next slide, please. So surface tension is basically, on the picture on the right side is a liquid surface with surface tension at the top, where you automatically have a pull inwards, and then natural cohesion that pushes the water outward. So on the surface, with the surface tension, it allows objects to float. And then what actually changes surface tension is the difference in temperature or just more surface area. The equation below is the Edgel's rule, which is a representation of molar mass, rho, or density, the critical temperature of the actual fluid, and the temperature of that fluid at any point in time, with a constant as well. And then you can see that if you rearrange the equation, you can get a relation to how all of that affects surface tension. So next slide. So this is an example of surface tension. If you can hit play. It's an experiment or just a visual representation of salt and water. And then on the right side is soap, and how soap has a lower surface tension than water, and how, if it'll go a little bit, when you place the soap inside of the water, it seems to shoot out. But this is because of the difference in surface tension. On the outside, you have a higher surface tension than, the water has a higher surface tension than the soap. So then the gradient of the surface tension and of the soap allows a difference in, I guess, surface tension. I feel like I'm saying that a lot, but it seems to shoot out to the rim. Next slide. This is gonna keep replaying. So how does Marangoni effect play into engineering applications? So one of the main things are in microfluidic devices, which are devices that on the surface have a small liquid film, and the way that the Marangoni effect plays into this is that you can manipulate the droplets of fluid onto the actual device, and it's used in micro-nano engineering and other small devices that if you touch on the actual surface, it can mess it up. But with fluids, whether it be water or any other type of fluid, it won't disturb it as much. Another engineering application is materials processing, which is basically welding. So when welding, you have a higher surface temperature and a lower surface temperature from the weld and from the metal itself. So then the pulls of the actual weld are drawn to the lower surface temperature, and it allows for more even welding pulls and more even welds for the actual welding process. And then you also have semiconductor cleaning, which is basically where you spray silicon wafers with some type of fluid to remove the staining of that from the to remove any solvents from the surface without actually causing any stains to the silicon wafers. And then lastly is enhanced oil recovery, where you shoot carbon or CO2 into the surface, into the ground, which has a difference in surface temperature, surface tension, and allows you to extract oil at an increased rate and increasing EOR by at least 30%. And in conclusion, the Marangoni effect is caused by surface tension, which creates tangential force. Temperature difference drives this force, since temperature is a key factor in surface tension. And then the Marangoni effect competes with buoyancy and influences boiling limits, but also is involved in manufacturing processes. And yeah, that's the Marangoni effect. Any questions? Thank you.